Hi there everybody, and how are you guys doing? Well, are you ready for another exciting lesson? Well, welcome to iTTV, and my name is Joel, your tutor for this lesson. So alright guys, so we have started on our first chapter, which is called Number Bases. And in the previous lesson, alright, we have looked extensively at the three bases, alright, that we have, alright, encountered right here in this chapter. Base 2, base 8, and base 5. Okay, so remember, alright, what are the bases, alright, all about, the digits, alright, in each base, alright, and so on. Alright, in this lesson, you will learn to, firstly, convert numbers in base 2, 8, and 5 to base 10 using the expanded notation method. Secondly, express a number in expanded notation as a number in base 2, 8, and 5. And thirdly, convert numbers in base 2 to base 8 and vice versa by the grouping and 4-to-1 method. Alright, okay, so that is what we will be taking a look, because remember, a number in a certain base, for example, in base 2, can be converted to another base. Alright, and we are going to take a look at converting numbers in base 2, 8, and 5 to base 10. Okay, now let's take a look at this flow chart right here, which will take us, alright, through all the processes needed, okay, to actually convert a number from a certain base to another base. Alright, I want you guys to start from the middle there, base 10. Alright, so if you have a number in base 10, we can change it, alright, to a number in base 5, or to base 2, or to base 8 by using the repeated division method. Okay, and we have looked at this method in the previous lesson. Now, if we have a number in base 5, or base 2, or base 8, and we want to convert it back to a number in base 10, we use the expanded notation method. Okay, we will be taking a look at it shortly. Alright, but now I want you guys to take a look at base 2 and base 8 right there at the bottom. Alright, changing or converting, alright, between base 2 to base 8, alright, will require, alright, a unique method. Okay, because we can use a certain method which we call it the grouping and the 4-to-1 method. Okay, so that is the second part of this lesson later on. Okay, now let's take a look at converting numbers in base 2, 8, and 5 to base 10 and vice versa. Okay, so remember, alright, remember now, a number in base 2 or base 8 or base 5 to base 10, the common base, remember. Alright, so let's take a look at a few notes right here. The conversion of a number in base 2, 5, and 8 to a number in base 10 involves, alright, step 1. Write the number in expanded notation. Okay, so we have learned how to write a number in expanded notation in the previous lesson. And in the second step, write the expanded notation as a single number. Okay, so there are only two steps needed, okay, to do this conversion. Okay, so a number in base 2, 5, or 8 to base 10. Okay, now let's take a look right now at our first example. Convert the following numbers to a number in base 10. A, 110 in base 2. B, 4075 in base 8. And C, 324 in base 5. Now let's go over to the board, alright, to answer this question. Okay guys, now let's take a look at our first number, which is a number in base 2, 110. Alright, so 110 is a number in base 2, and we know that base 2 only consists, alright, of the digits 0 and 1. But now we can actually convert this number, alright, to a number in base 10. Okay, because they will have exactly the same value, but they are just expressed differently, alright, because they are in different number bases. Okay, so remember the two simple steps. Okay, firstly, 110 in base 2. Step 1, remember early on, write down this number in expanded notation. So we start from this 1 right here on the far left. 1 multiplied, okay, by 2 because we are in base 2 to the power of, remember we always start, okay, alright, to the power of 0, 1, 2. Okay, so like that. Added with, okay, let's move, alright, to the right. The next digit will be 1, right? Okay, multiplied with 2 to the power of, remember, 0, 1. Okay, the place value. And then added with 0 multiplied by, okay, the place value of the digit 0 is 2 to the power of 0. Okay, so this is the first step. Write the number in expanded notation. Okay, and next, alright, sum up, alright, this expanded notation as a single number, and your number that you get will be automatically a number in base 10. Okay, so what is 1 multiplied by 2 square, which is 1 multiplied, okay, by 4. Okay, added with 1 multiplied by 2, and this will give you 0. Okay, so what do we get here is 4 plus 2, which is 6. Okay, so this 6 is, alright, a number in base 10. Alright, now let's take a look at a base 8 number. 4075 in base 8. Okay, how do we convert it to a number in base 10? Very simple, okay? Remember, the first step is to always write it down in expanded notation. Okay, so expanded notation, alright, we always start from the far left, 4. Okay, multiplied, okay, by the place value of that digit 4, 8, because it's base 8 to the power of 0, 1, 2, 3. Okay, added with 0, multiplied by 8 square, okay, remember it goes smaller, added with 7, alright, multiplied by 8 to the power of 1, plus 5 multiplied with 8 to the power of 0. Okay, so this is just the expanded notation. Okay, now we have to apply step 2 to get our number in base 10. Okay, so let us find out what is this. 4 multiplied by 8 cubed, okay, gives us, alright, 2048. Okay, this will give us 0. This will give us 56. Alright, and 5 times 8 power of 0 is 1, so it's added with 5. Alright, so don't forget to sum it up. And what will we get? 2109. Okay, or 2109, and this will be our number in base 10. Alright, and now for a number in base 5. 324 in base 5. What is the number in base 10? Okay, we have to convert it. So same step. Let us write it in expanded notation. So expanded notation means, alright, don't forget writing the number as the sum, alright, of the products of every digit and its place value. So 3 multiplied by 5, okay, square, plus 2 multiplied by 5 to the power of 1, plus 4 multiplied by 5 power of 0. Okay, so what do we get here? Alright, let's sum up everyone. So this is 75. Okay, this is easily 10. And this, be careful, is 4. Okay, so what we will get is 89. And this is in base 10. Alright, now let's take a look at the next example. Given that 521 in base 8 is equivalent to x in base 10, where x is an integer, find the value of x. Alright, so since you know now how to apply the two-step method to find or to convert, alright, a number from base 8 or any other base, 2 and 5 to base 10, I'll just give you a while to try out this question. Alright, so we'll discuss it in a short while. Alright, now let's take a look at the solution. Okay, so a reminder, the steps. This question requires you to convert the number in base 8 to base 10. You will have to first write the number in expanded notation and then sum it up. Okay, so 521 in base 8. In expanded notation, it will be 5 multiplied by 8 squared plus 2 multiplied by 8 to the power of 1 plus 1 multiplied by 8 to the power of 0. Sum it up. 337 in base 10. Therefore, x is equals to 337. Okay, now what about the reverse? Alright, let's take a look right here. Given a number in expanded notation, can we actually write it down as a number in base 2? Let's look at this example. Express each of the following as numbers in base 2. A. 2 to the power of 3 plus 2 to the power of 1 plus 1. B. 2 to the power of 4 plus 2 to the power of 3 plus 2 to the power of 0. Alright, so how do we actually write these numbers in base 2? Let's take a look. So we have to realize that what has been given to us is actually the expanded notation. So what we must do is, alright, separate the place values right now. Alright, so we have 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, and 2 to the power of 0. Alright, so the number is 1011. So therefore, 2 to the power of 3 plus 2 to the power of 1 plus 1 is equals to 1011 in base 2. Okay, so once a number is in expanded notation, okay, and you want to convert it to base 2, remember, just look at the digit in front of the place value. Okay, and then, alright, write them down together. Okay, what about B? We have 2 to the power of 4 plus 2 to the power of 3 plus 2 to the power of 0, right? Okay, so it means that for 2 to the power of 2 and 2 to the power of 1, the number is actually 0. Because 0 multiplied by 2 to the power of 2 and 2 to the power of 1 is actually 0. So, the number for each place value will be 11001. So therefore, the number in base 2 will be equals to 11001 in base 2. Alright, next example. Why don't you guys try this out? Express the following number as a number in base 8. 5 multiplied by 8 cubed plus 2 multiplied by 8 to the power of 1 plus 7. Alright, so what is the solution? Okay, remember, okay, just prepare a simple table. Alright, the first row is for the place value. So since we are having a number, okay, in base 8, so the place value will be 8 to the power of 3, 8 to the power of 2, 8 to the power of 1, 8 to the power of 0. Now, what about the number? Okay, so remember, in expanded notation form, okay, digit multiplied by its place value. So the digit will be the digit involved, alright, in the number in base 8. So for 8 to the power of 3, the digit is 5. For 8 to the power of 2, the digit is 0 because there is no, alright, value there. For 8 to the power of 1, the digit is 2. And for 8 to the power of 0, the digit is 7. So, the answer is 5027 in base 8. Alright, now, next example. Express the following number as a number in base 5. 3 multiplied by 5 to the power of 3 plus 2 multiplied by 5 to the power of 1. Alright, so what is it? Okay, so one look, you should be able to take a look right here because this is in expanded notation. But notice why the place value 5 to the power of 2 is not there. Is because, alright, it is multiplied with a 0. Okay, so what do we have? Same thing right here. Prepare the place value. Okay, and the number for each place value. So what do we have is 3020 in base 5. Alright, now let's take a look at a couple of objective questions. Alright, if 5 multiplied by 8 to the power of x plus 2 multiplied by 8 to the power of 3 plus 7 equals to 2057 in base 8, then the value of x is it A, 1, B, 2, C, 3, or D, 4? Alright, so for the solution, take a look, alright, at the digit 5. Alright, because the digit 5 multiplied by its place value, alright, will be 5 multiplied by 8 to the power of 1, right? So it means that x has to be 1. And the answer is A. Alright, next example. Why don't you guys try out this one? If 2 multiplied by 5 to the power of 4 plus 3 multiplied by m plus 1 is equals to 20301 in base 5, the value of m is it A, 0, B, 7, C, 10, or D, 25? Alright, the solution will be D, 25. Alright, because m is actually 5 to the power of 2, and 5 to the power of 2 is 25. Alright, so what we have learned in the first part is converting a number in base 2, 5 or 8 to a number in base 10. Okay, and then just answering questions which relate to that. Now in this part, we're going to learn a special conversion. Converting from one base to another, from base 2 to base 8 and vice versa. Okay, so now if we have base 2 and base 8, a number in base 2 can be changed to a number in base 8, okay, straight away. How do we do it? Alright, let's take a look. Converting a number in base 2 to a number in base 8 involves step 1. Sort the digits into groups of 3 from right to left. Step 2. The first digit in each group represents 4 in base 8. Second digit represents 2 in base 8. And third digit represents 1 in base 8. Step 3. Adding the values represented by each digit together will convert the number in base 2 into base 8. Alright, now let's take a look at this conversion. Convert the following numbers in base 2 to numbers in base 8. A. 10111 in base 2. B. 110 101 011 in base 2. Now let's go over to the board for this question. Alright, so in A, we have the number 10111 in base 2. Now how do we convert this number into base 8 by using this special grouping 4-to-1 method? Okay, very simple. Okay, so what do we have to do? Just, okay, write the number down. Okay, and now we group it in groups of 3. Alright, so how do we do it? Groups of 3 from the right to the left. So we have 3 digits. Okay, it is already one group. Okay, so these 3 will belong to one group. Okay, but what about now, you might be asking, we have only 2 digits here. Don't worry, because actually there is a 0 here, okay, which, alright, has no meaning, right? 0. Okay, but we just add that to make it, alright, look as a group of 3. Okay, now what do we have to do is realize that, okay, if there is a digit 1 in this place, it will carry 4 in base 8. Okay, if it is in this place, if there is a 1 here, it will carry 2 in base 8. If the 1 is here, it will carry 1 in base 8. So look carefully. Now, there is 0 here, 0 here, so we don't have to, okay, do anything to it, but there's a 1 in the middle, right? So remember that if the 1 is in the middle, it carries okay, 2, all right, in base 8. Okay, what about this side? Can you see that there is a 1 on each position in the group? So the 1 here, okay, carries 4, right? The 1 here carries 2 in base 8. So we have to add it up. And the 1 here carries 1 in base 8. Okay, so can you see that here we have already 2. Here 4 plus 2 plus 1 gives us 7. So 2 7 in base 8 will be equivalent to 1 0 1 1 1 in base 2. Okay, so let's write down the conversion. That's all. Okay, so remember to actually remember the digits and how much value does it carry. Now let's take a look at a longer number in base 2. Okay, let's write down this number again, okay, so that we can group it nicely. 110, 101, 011, okay, in base 2. Okay, so what do we have here? Okay, pretty simple. Okay, so what must we realize is we can group it right now from the right to the left. One group, another group, just nice. 3 groups. Okay, so what do we want? Okay, look at this first group right here. This one on the left, okay, every time you see it, okay, in base 8, it will carry a value of 4. Okay, but now we have to add it with 2, right? Because this one carries a value of 2 in base 8. So 4 plus 2, okay, 6. Now, 101. Okay, forget about the 0. 1 here and a 1 here. The 1 here brings 4. The 1 here brings 1. 4 plus 1, 5. Alright, what about this group? 0, don't look. This one carries 2 in base 8. This one carries 1 in base 8. So 2 plus 1, 3. Okay, so therefore 110, 101, 011 in base 2 is equivalent to 653 in base 8. Now let's take a look at the other way around. Converting from one base to another, base 8 to base 2. Now you are able to convert a number in base 2 to a number in base 8. Let's see how we change a number in base 8 to a number in base 2. Okay, it's basically the reverse process. Convert the following numbers in base 8 to numbers in base 2. A. 625 in base 8. B. 4703 in base 8. Okay, so now just remember the grouping method just now. Okay, now we're actually going to apply the reverse. So let's take a look at A. 625 in base 8. So for every digit in the number 6, 2, and 5, we have to take a look and find out how each digit originates from the combination of 4, 2, and 1. So 6 is 4 plus 2, right? Therefore, it will be 1, 1, 0. 2, it will be 0, 1, 0. Okay, so just work backwards. And 5, it will be 1, 0, 1. Okay, so the most important thing here is the combinations. Therefore, 625 in base 8 is equals to 110, 010, 101 in base 2. Alright, and B, 4703. So each digit, let's check out the combinations. So to get a 4, we have to have a group of 100. To get a 7, we must have a group of 111. To get a 0, very easy, 000. And to get a 3, to get a group of 011. So therefore, now just put all of them together. 4703 in base 8 is equal to 100, 111, 0000, 11 in base 2. So alright guys, we have learned, okay, a few important conversions, alright, in this lesson. So to just wrap up, take a look again at this chart as we have seen in the early part of this lesson. Okay, so if you're given a number in any base that we have learned, you should be able to change it or convert it to a number in another base. But remember, what is the technique that is involved? Is it repeated division? Is it expanded notation? Okay, or is it the grouping method? Alright guys, so that's all that we have for you until now. Alright, in this lesson, I'll see you guys in the next lesson, alright, for more. So until then, it's goodbye.